Hey guys, today's topic is the consistent hashing. So in the distributed system, data is distributed to multiple nodes or server. So to search which server is owning the which data key, we can use multiple searching algorithm. So one basic searching algorithm is the hashing. So now what is mode hashing? So in this we calculate the hash for the given key and then we perform mode function on the hash value to get the node. So here I'm using number of servers equal to 3. This will help us to calculate the mode of the hash. So let's take an example. I am taking 4 keys A, B, C and D. So I use some any hashing algorithm and calculated the hash and then I performed mode function using number of servers equal to 3. Then the outcome of the mode function is equal to 0, 1 and 2. So 0 means node n1. So that means A will serve by n1. 1 means node n2. That means B and D will serve by node n2. 2 means n3. So C will serve by n3. Now the problem with mode hashing is the rehashing. Now what is rehashing? So in the distributed system, we have to add or remove the servers on demand. Our mode hashing is directly depends on the number of available servers. If number of available servers are changing, then we have to recalculate the mode of all the keys. So that is the main problem. So we have to recalculate the mode of all the impacted keys and impacted keys need to move to new servers. Let's understand this impact with this example. So same example, we have a 4 keys A, B and C and D. So initial available number of servers equal to 3. Now let's suppose one node n3 is down. Now hash will remain same, but we have to recalculate the mode using number of servers equal to 2. So mode of A with the number of servers equal to 2 still remains 0. That means data A will serve by node n1. Mode of B and D will change. So previously B and D served by the n2. Now with number of servers equal to B and D will serve by n1. Same for C. C will serve by node n1. So in this case, we can see we have to move most of the data B and D in n2 and n2 is working right now. But still we have to move B and D to node n1. So to improve the movement of data key, so we can use consistent hashing. So in the consistent hashing, our mode function is not directly depends upon the number of available servers. In this, our mode function is dependent upon the hash size. So let's understand with this example. So first we have to place our node and data key on this circle. Now we have to start from the any node in the clockwise direction. So let's take example for n1. So start in the clockwise direction from n1, same for n2, same for n3. Now which server will serve the which keys? For that we have to check the data keys which are in the path of clockwise direction. So B and C in the path of n1 clockwise direction. So B and C will serve by the n1. D is in the path of n2 clockwise direction. So D will serve by n2. Similar for A will serve by n3. Now how we calculated the hash? So to calculate the hash and the mode. So for hashing, we are using same hashing function, and for the mode we are using 360 as a denominator. So we can took any denominator here. It depends on your hash size. So after calculating the mode, so that means data key A mode is equal to 300. That means data key A will serve by n3 and B and C will serve by n1 and D will serve by n2. Now let's see what happen if we apply same situation here where n3 node is down. So if n3 node is down, now we have a number of servers equal to 2. So good thing is here our B, C, D still remains same. B, C will serve by n1 and D will serve by n2 because our mode will not change, hash will not change, and so serving will not change. But previously A will serve by node n3, now A will serve by n2 because after calculating the mode of A, then that is giving 300 and that is in the path of n2 clockwise direction. Now the problem with the consistent hashing is the skewed nodes. Skewed node means uneven data distribution. So when we are adding nodes and when we are removing the nodes, so we will come up with the situation where some nodes are serving more request as compared to other. So in this example, n1 is serving b, c and d, but n2 is serving a and n3 is serving nothing. So that is basically uneven data distribution. To solve this problem, we should use multiple virtual nodes. So what is multiple virtual nodes? So virtual nodes are just points on that circle. So we can create multiple virtual nodes. So here one physical node I am dividing into three virtual nodes. So here I created three n1, n1, n2 and 3. So basically physical server remains same, but our virtual nodes increased. So now I divided the circle into 9 points and we will see the better hash distribution. So previously n1 is serving for 0 to 120. Here n1 is serving for subparts like 0 to 40, 120 to 160 and 280 to 320. Now what happen if n3 is down? So now we are using same situation here to analyzing the impact. So if n3 is down, now someone need to serve the load. So we will apply same logic here. We will move into the clockwise direction. So n1 will serve 320 to 360 and 40 to 80, and n2 will serve for 200 to 240. So we can see failure of n3 and the distribution of n3 load divided to n1 and n2. So in the consistent hashing, in the worst case, we have to move m by n keys, where n is the total number of nodes and m is the data keys on one node. Yeah, thanks.